Now and after explaining what the cross product and dot product mean, we can explain torque and energy in efficient way. Torque is the measurement of the force that can cause an object to rotate about an axis. Its unit is a Newton meter. Since electric dipole has different charge, then there is always the repulsive force between the positive and the negative charge. However, since these charges cannot be far away from each other because they form a dipole, they start rotating, producing a torque. The torque is equal to the cross product between the dipole moment vector and the electric field vector, which is equal to Q times E times D times the sine theta, or P times E times sine theta, where Q is the electric charge, E is the electric field, D is the distance between the two charges, P is the dipole moment, and theta is the angle between the x-axis and the dipole moment direction line. Torque is the result when the force acts on an object and move it by some distance. Since the dipole is rotating, then there is a work done. To calculate the portion of this work, dW, we have to multiply the torque by a portion of the total rotating angle, d theta, which is equal to P times E times sine theta times d theta. Now, to find the total work done while the dipole is rotating, for example from theta 1 to theta 2, we have to integrate the portion of work dW from theta 1 to theta 2. Moreover, because the dipole is rotating, then we can consider the dipole as a mechanical system. Assuming that there is no friction and the mechanical energy is conserved, then the dipole is losing potential energy while it's gaining speed, and vice versa. To calculate the potential energy of the dipole, we have to use the following formula. This is the end of the video, guys. I hope that you enjoyed the video. Don't forget to like this video, subscribe the channel, and have a comment if you have any question. See you in the next video.